Next, let's talk about sum, difference, product, and quotient of functions. So remember, sum means addition, difference means subtraction, product means to multiply, which we're going to represent with a little dot, and quotient is a fancy word for division. What's really nice is you can just go ahead and directly add, subtract, multiply, and divide functions. As long as they are a function, you have to verify that they meet the criteria of being a function first. So the sum function, you just go ahead and add. The difference function, you go ahead and subtract. The product function, you go ahead and multiply. And the quotient function, you just go ahead and divide. So I think we should look at some examples of those. So if I have f of x equals 1 over x plus 2 and g of x equals x over x minus 1, let's find the difference, quotient, the product, and let's find the difference, the product, and the quotient. So first off, I'm going to take f minus g of x. I can verify that these are both functions. But let's go ahead and state the domain of them individually. So the domain of f of x is x such that x doesn't equal negative 2 because negative 2 plus 2 would equal 0. And the domain of g of x would be the domain such that x doesn't equal 1 because 1 minus 1 would be 0 and we can't divide by 0. So f minus g of x is going to be f of x minus g of x. So I have 1 over x plus 2 minus x over x minus 1. Now when we're subtracting fractions, they have to have the same denominator. So I'm going to have to rewrite this as 1 over x plus 2 and then multiply by x minus 1 on the top and the bottom in order to have a common denominator minus x over x minus 1 times x plus 2 over x plus 2. I recommend don't multiply everything out, just keep it factored. So I've got x minus 1 over x plus 2 times x minus 1 minus x times x plus 2 over x plus 2 x minus 1. That's going to give me x minus 1 minus, I'm going to go ahead and distribute this, x squared minus 2x over x plus 2 x minus 1. Oh, this is so much math for early on in the semester. Okay, so I've got x minus 1 minus x squared. So I've got minus x squared minus x minus 1 over x plus 2 x minus 1. So much fun. X plus 2 x minus 1. Then I'm going to go ahead and pull out a new factor of negative 1 up on our numerator because we don't like negative leading exponents. And then I see if I can factor this quadratic. Are there any factors of AC that add up to B? Are there any factors of 1 that add up to 1? No. So we are fully simplified, and our new domain of f minus g of x includes both negative 2 and 1. We have to include both those factors. So our domain is x such that x doesn't equal negative 2 or a positive 1. And typically you'd want to write those in numerical order, but I won't take off points for this. Let's go ahead and clear this and try another example and change to a better color. So I've got f times g of x. What's really nice is because these are both rational functions, I can just go ahead and multiply straight across, because when we're multiplying fractions, we multiply the numerators and we multiply the denominators. I'm just going to go ahead and rewrite our domains so we have them if we need them. So f times g of x is really f of x times g of x. So I've got 1 over x plus 2 times x over x minus 1. That gives me x over x plus 2 times x minus 1. Again, keep it factored unless the homework instructions tell you otherwise. Again, my domain includes both of these values. So it's x such that x doesn't equal -2 or 1. All right, let's try f divided by g of x. And I'm just going to go ahead and erase down here to find the quotient function. Remember, when we're dividing fractions, we flip. We keep the first fraction the same. We change from division to multiplication, and we flip the second fraction. So I have f over g of x. That's f of x divided by g of x. So I have 1 over x plus 2 divided by x over x minus 1. Oh, I was trying to erase and it wasn't working. So that gives me 1 over x plus 2 times, because we keep change flip, x minus 1 over x. So I have x minus 1 over x plus 2 times x. Now I need to know my function's domain and my range. So we have to add in this variable, right? So if I set my denominator equal to 0, I got x plus 2 equals 0 and x equals 0 by the zero factor property. So I've got x equals -2 and x equals 0. So our domain of f divided by g of x is going to be x such that x doesn't equal 0 or -2. Now you might be saying, what do we do about the domain of g of x? Well, that has to be included too for all of these functions when we're adding, subtracting, or multiplying or dividing these functions. What we're doing is we're finding the intersections of their domain, so we have to include all values that are excluded. So we need to amend this in order to include a positive 1. So this would be the domain of our quotient.